see. Let me just refresh Twitch. Yeah, that looks live. Perfect. Hello everyone. Welcome back to more of the compiler project. So last week we only streamed on Tuesday, but we made a lot of progress. On Tuesday we finished writing the assembly part, which means we are now able from bytecode to generate an image. I had to reboot my computer, so I don't have the same session, but if I remember correctly, last time we were making images out of like bytecode like this, like we just write the instructions manually and we would generate images. And I think we have. Is it not? How's it called? Oops. Or is it fast? Yeah, that was our first generated program that we wrote last week from bytecode. It does basically nothing. That's just the main that jumps into this function that just does a print of one character and a new line. But, you know, from bytecode, we are able to generate an image, and we had tried it with npit, and it works. So, at this point, the next step is we've done parsing the source code into an AST. We've done transforming bytecode into an image. We just have to do what's left between AST and bytecode. And that's like a lot of steps, of course. First, we're going to start with the more compiling phases. We're going to do renaming, type checking, simplifying, and then lowering into IR. And this evening, I'm going to start with the name checking and type checking. Well, name resolving, I should say. That's one part for which I know the shape of what I'm trying to do. I know the overall shape that it's gonna like be when we're done, but I haven't spent as much time prototyping in my head before the stream as I have other parts. So where in the past I've tried to make it so there is like one goal per stream, one like achievable thing per stream, this evening it's a bit less so. It's just gonna be let's make progress on the renaming things and see where it brings us. One thing, for instance, I am not sure about is whether I want to do the name resolving and type checking at the same time, or if I want to do it in two separate steps. Um, of course, it would be easier to do it in two separate steps. I rename everything without doing any type checking, and then I do type checking with all of the names resolved. But maybe from a performance perspective, it would be more interesting. Like, it would be better to just like do it in one traversal of the AST, but maybe that would require doing some tricky things with like circular definitions. So I think I'm going to start with name resolving first, type checking second, as separate phases. A big unknown that we have to solve is also the question of the representation. For now, our AST is parametered by a phase that indicate where we are in the process, to which we associate a bunch of types that like declare what should be like attached to the AST at different parts of the AST. For now, we're attaching location information. This is likely to change. And perhaps as a result, I'm going to rethink this approach of associated type families, of how we want to associate types with different faces, if we realize that actually most of them share the same thing. Perhaps it's just going to be like annotation type, and it's going to be the same through the AST. So again, I have less of a strict goal this evening of we achieve this thing, and rather we start making progress on the name resolving and maybe the type checking, depending on how well this goes. And we'll see where that leads us. And based on that, I'll probably try to have next stream be a tiny bit more self contained. Okay, with that, I think let's go. So, here's our AST. So here's our phases. For now, we have only one phase, which is parsed, and we're gonna add another one, which is how do we name this actually? Named or name resolved? I'm not sure. Or renamed, perhaps, because it's a process of renaming. We're going to take the names that appear in the code and associate new names to all of them. The goal is going to be for every single name thing that appears in the code to associate some kind of canonical name. This is probably the part where we're going to do some of the name mangling of functions and everything. It's like, okay, we need to be able to identify clearly this is a local variable in this function and it's this one, or it's a global thing defined in this other module and it's this mangled unique name. This will also help us deal with like name conflicts and everything. One thing I haven't decided on yet, which will have an impact on how we name things, is how I want to have paths given as an argument to the compiler. Do we just like give the main and every other file is relative to main? Do we like give a project root and a main, and like do we try to do incremental compilation? All of those things I think I'm gonna delegate to later, because we can get something that works without without making anything complicated there. So I think for now I'm gonna make it very simple, where we compile one file and all of the others are deemed relative to it, and we'll move to libraries and step-by-step compilation at a later stage, probably after the 1.0 is done. So yeah, let's do a new phase. It's going to be renamed, and I'm going to just for now duplicate this absolutely monstrous instance declaration, which is what are the types associated with a given phase. And for now, we're going to leave it the same. This is one of those things where, again, this is going to change. I don't know exactly how yet, but this is going to change. So, what is renaming going to be? It's going to be traversing an entire module to replace basically every identifier, maybe not every identifier, but a lot of them, with a new type, which is going to be name, which is going to declare as much as possible, like contain as much as possible information about the thing. So, a thing I'm wondering as well is when I give the name of something, do I think like in the here in the type alias info, the name is there as well. Should this be the changed name, the resolved name, or should this be the original name? And I think this should be the original name, because this is information about the type alias as it appeared in the source code, while the resolved name is what I'm going to use for like solving name, like to do name resolving basically. So not all identifiers are going to be our new name type. I think the most crucial thing is going to be in expressions. Specifically, I think basically every path info is what's going to be changed. Every time we make a reference to something that is a path, which is also how we do a type, this is how I think we are going to, this is what we're going to change. Every reference to a path, to a name, is going to be changed to some resolved thing. So I think logically the thing to do here would be to have a new type in the type family, which is a path type, I guess, or name type, which in the past version will be a full path, and in our renamed version will be whatever our new name type is that points to the actual unique name we have decided. So this would be something along those lines. Path type. I wonder, like, I went with the option of having all of those types ahead of time and then remove the ones I don't need. Maybe it would have been better if I had just added the ones I needed rather than going completely overkill at first, because this makes the code a tiny bit more complicated than it needs to be. But that's not gonna be location. It's gonna be the path info. which is no longer going to be required past the first phase. So this is no longer going to be path info. It's going to be its own type. There's a few places as a result where we're going to need to change this. So this is going to be a path type. I think we named it. Should it be name type? Maybe name type is better. So let's go back here. Name type. So when we're done parsing, this is going to be a path expression. For now, in the spirit of like maybe adding all of those types ahead of time and trying to remove them after the fact was a mistake, I am going to use the same for name, like path towards a variable, path towards a type, because at the moment that's exactly the same type. And I'll introduce a new one if we decide we need the specificity, which we might not need. I'm going to call the type unique name. I don't know if that's a good name. We'll figure that out as we go. So now that means every time I have a path expression or type expression, I need to replace that with a name type of the phase. Wait. Do I have a constructor with the same name as a type? No, so what's the name of the type? Is it... It's path info, not path expr. Okay. So here, yeah, that's exactly the kind of thing we wanted. Here, this is a kind of expression where the part of the expression that is like a reference to a variable or a function or a global constant or anything, and it is given by a name, which is a path, we are going to want to use the name type thing here. When we're done parsing, this is going to be still the same path info used to be, but after the renaming phase, it will be our new unique name type. I see a path info here. Yes, that's also a name type. A reference expression that's also to a name type. And this is where we're going to be, during the compiler phase, we're going to be checking some of the assertions like, hey, this needs to be a local variable that's in scope. It could be a global, probably not. I guess we haven't decided that. But I guess in the syntax of the language, we don't have any syntax for declaration of variables outside of functions. And we only have constants, which are probably going to be inlined most of the time. So I think, no, we probably don't want that to allow for non-local variables. Okay, next, where else do we have path info? Only in the type itself, perfect. And do we have any type expression anywhere? We do here. So likewise, this is a name type. As in the type alias, the thing that we pointed name the type to um, is gonna be another path to another type. I'm even questioning the need for like any other annotation. I have like all of those location annotations. One thing I had in mind was maybe to annotate with the actual type of expressions. And I guess as the output of the type checking phase, when we're done the renaming and the type checking, at that point, there should no longer be any error that stems from the user's code. By that point, we should have caught all of the errors in their code. Any error that happens after is in our code, which means we can probably ditch source location info after the type checking phase, which means we can probably replace the annotations at that point by type annotations, which will help the third and the last phase, which is the simplifier, which will do some very basic AST transformations for the purpose of simplification optimization, like constant unfolding, for instance. Yeah, yeah. Again, still, I'm thinking out loud about this thing that I'm not happy about. But for now, type expression. All of those are going to be name type. Except not that last one. Oh, that suggests. This suggests that since we're giving the path to the type arguments, our unique name thing will need to be able to preserve the argument, the type parameters. I didn't think of that. Okay. Um, so what do we need to have in a name? What is going to be a resolved unique name? And do I want to include type information at this point? Like, this name is actually a struct in this particular thing or not? I don't think so. I think that's purely the responsibility of type checker. I know some implementations do that of like storing in the resolved name after the name resolution of like, hey, this is pointing to a constant, this is pointing to a function, this is pointing to a variable. I guess the upside of doing so is that I can do the type checking without having to do any lookups in the other modules. As in, I use the other compilation modules only for the purpose of name resolving. Like, yes, this function foo, like this name foo points to a function defined in that other module. I get the relevant information as part of the name, as part of the resolved information. And that means when I do the type checking, I no longer have to do a lookup of like, oh, this was name foo in that other module. What's the type of that? I carry the type information with me in that unique name. If I do that, I think it would make more sense to not treat this type as a name, but rather as like one of the exported symbols, and I just get the full symbol that would be exported out of the module. But does that mean duplicating information from the AST is the thing? Because I don't want to duplicate information from the AST at this point. Because that would be basically a duplication of this. It would be a name is something that points to a declaration somewhere or a local variable. I guess I could just do a wrapper around this that avoids the duplication, I guess. So that would be means there's two kind of names. There's the names pointing to a top level declaration that will take as an argument. I guess the identifier by like the unique identifier that uniquely identifies the name, which will be based on the module name in which it appears. I so the question is, would it be possible to optimize the resulting Pete images for beauty? That's something I have been thinking about. For now, the structure is very hard coded, as we've seen so far. With this one, for instance, the structure is very much like each column is a function, and like the colors are like there's a bit of choice, but the color transitions are hard coded by which instructions we're using. However, a lot of this could be spaced a lot more. For instance, like this is scaled quite a lot, but the actual image is only like 20 pixels large. We could arbitrarily insert a bunch of white space in between functions and around functions. And since a lot of that white space would never be encountered by the interpreter during normal evaluation of the program, we could put whatever we want there. So we could try to like, okay, here's the base image that we want to emulate, insert our program, the immutable parts like the columns of the functions and everything, but spaced out as much as possible. And for each of them, choose a starting color that minimizes the contrast between the actual function and the image underneath. And we could make programs that are just arbitrary images, or at least modified version of arbitrary images. But that's not something I'm planning to do in the first pass of the compiler, but that's something that would absolutely be possible and something that like could be a fun project afterwards. Because basically like the path of this is this image uses the side of the image as like a guardrail kinda, and this here is the start of the addressing instructions that like redirect the execution to another place, and each of those is a function with the different entries. But that means a bunch of those columns are never used. Like this column are never interpreted. So as long as they don't match any of those colors, they could be anything. So if we're using the name as like, okay, this is where that thing is in another module, and this is the associated information so that we don't have to redo lookups when we actually do the compilation. Maybe name is a poor name for this type, ironically. A reference, a symbol, a named symbol. I think symbol is probably, but I think then it creates some confusion between the actual symbols exported by a module and the underlying ones at compilation time. Because, maybe resolve the named. Maybe this carries everything we need. So, this needs to have the unique name that is going to be like the result of the what's the word I'm looking for? The thing that C++ and Rust and other languages do, where they create a unique name based on the module name, the type name, the parameters. Not mangling. There's another word for this that I'm not remembering. Mangling. Oh, it is mangling. Okay, thank you. Yeah, so I think this is where the mangled name would be, so that we have a unique identifier for the thing. Um, oh, but that's... If we do this... I was going to say, it means we also need to adapt not just all references to other names in the module, but also all the declarations in the module. But we might not need to do that as long as our mangling is deterministic and consistent, because that way we can just say, oh, that constant is from that module, therefore the mangled name is, and when we actually compile the module, then the mangling will result in the same thing. So we don't need to necessarily persist the mangling in the AST at this phase. Okay, so that's going to be... and I might use... and even if for now a mangle name is just... Yeah, that's a good... That's a good point. Like, mangle doesn't sound great, and qualified would be... Maybe this is where actually I use unique name. I think for now it's just going to be an alias to identifier, but at the very least it's going to make very explicit in type signatures what's happening. So that's going to be the unique name. So that's a top-level declaration, which means, okay, we found a name and it points to a function or to a type in a given module, including this one. We probably want to include the module name in which it was declared, even though the unique name might... Unless I assume that module names are unique, and at this point I don't do any mangling, and perhaps I never do any mangling, and therefore this is not an identifier. This mangled is a tuple of, like, or maybe not a tuple, a new type or something, which is module name and identifier, as in which module is this top-level declaration found, and what's its name in this module. Given that there's not going to be any conflict of names in this, probably fine. That being said, with generic type arguments to functions, we are going to want to do instantiation and therefore have instantiations of... But that's maybe not something we need to do at this point. Maybe that's something we need to do when we generate the IR, where we are going to generate the IR for each function as if it were a different one with a different mangle name based on the type arguments, if needed. I don't think it's needed at this point. That being said, that means I'm assuming that the path, all of the elements of the path are just the module name, and the last one is the identifier in the module, which I think is correct for our use case, because we don't allow function declarations within functions. We don't allow... Yeah, we don't allow anything that would require... that would, like, result in namespacing within a module. So maybe this is enough. So, okay, so a name points to a module name, an identifier within that module name. We don't do any mangling at that point. And I am guessing that if it is a top-level declaration, I can just copy a declaration. For now, this is incorrect, but I'm going to say that this is a declaration passed. I think... Oh, but that's not necessarily... I was going to say that's... Like, when we compile a module, we have access to the fully compiled other modules, because, okay, if A depends on B, we compute the symbol table of B to have, like, the fully resolved... Maybe not lowered into IR, we probably still want to be at the AST level, but we have the fully resolved AST of the B module we depend on, and A module has therefore access to the fully resolved A. The problem with this is, if we do this, and we say, for instance, like, this is a declaration that is fully resolved, or whatever the name of the phase ends up being, if we end up pointing to something in the module we're currently compiling, we have a bit of an issue. Because that means, for instance, a recursive function. A recursive function will be resolved as like, okay, there's going to be a new like resolve the name version of this particular function expressions, and one of the expressions is going to be a call to another function, and the call to that other function is going to be a top level declaration of that same function within the module, and we need to be able to identify that so that declaration cannot be fully resolved. Huh. That leaves me with, I think, two naive options. The first would be I make a separate case for this is pointing to a function that is already, like to a thing that is already fully resolved in another module, or this is pointing to something that has not been yet fully resolved because it is the current module, and I have another phase at a later stage where we replace all of those temporary, this is pointing to the same thing within the module with the proper fully resolved version. Or I changed the way the declaration is here to not have to worry about what phase we are in, so that this problem becomes irrelevant. I think I'm gonna have that problem no matter what, because when I go into the type checking phase, I'm going to have the fully resolved other modules, and I'm going to have my local module, which is only going to be renamed, and I'm still going to have to do the type checking there, which means I need to be able, for all the names, to check their type information regardless of whether they have been fully resolved and simplified yet, or whether they haven't. So, do I Another option is that I don't include the type information there at all, and I push the problem down to the type checking phase, where I guess I could write generic functions that, given a unique identifier within a module, and um, like regardless of the phase of the thing, extract the type information that tells me what the type of something is. However, the type of something will depend on the phase because it is at that point just string matching. Let me think about this. I am not convinced this is the right approach. Because, yeah, we want to be able. We want to be able. The point of this phase is to make sure that every name points to something, and perhaps do. No, I don't think we want to do any type checking at this point. We just want to check that all of the names point to something that is in scope, that there is no conflict of the names. As in, okay, this points to something named foo. There's only one thing named foo in context. This is fine. This declares something named bar. There is no other thing named bar in context. This is fine. And the output should be just something that tells us for each name we have found where we have found it, so that we can do, during the type checking phase, we can resolve the types of everything. Okay. So the upside of including type information within this resolved name means we don't have to do further lookups during the type checking phase because we've already done all of them at this point. Downside is we have to figure out a way to represent the relevant type information in a way that is independent of the phase of the compilation so that we can treat the current module the same way as we treat a dependency. I guess, in the spirit of making progress and seeing the issues as they arise, I think for now, I am not going to make more progress than this. I'm not going to include the type information within this resolved name. And when it's time to do type checking, I'll probably revisit this, but with a better understanding of what is required to do type checking, and therefore I'll be able to put the right thing there. So there's only two possible things. There is a top level declaration and I guess a local variable that is going to be local to a given function because all paths point to either something that is locally declared within the function or to a top level declaration somewhere else. And in this case, the module name is not required because it is based on this. Well, I mean, it is in the current module, so we can keep the identifier. However, is this a point where we want to assign a unique, do we want to assign a unique new name to make sure that we can, at the time where we lower into the AR, do we want to, yeah, we probably want to assign a unique name because there is nothing that says that we will never have name shadowing. For instance, a function takes an argument named x and does a for loop in which the name of the variable is x. We probably, at the time of name resolving, we want to make sure that we know that, okay, no, this variable x points to this one, the for loop variable, not the argument one. So we should do some renaming there to make sure that we point to the correct variable. And perhaps this is also something where, to simplify the type checking phase, we could here include some type information. Was this a let binding? Was this a function argument? Where did this variable come from? That will also help us do the type checking afterwards. Okay. I think for now, this is just going to be two identifiers. The original one and the new one. Because here, I don't think the mangling is going to be consistent because it's not going to only depend on the function and the number of things in the, it's going to depend on like the function and the order of the number of declarations in the function. And as a result, I think we need to do that, like assigning a unique name at this phase. Okay. So this is part of the analysis phase. So I'm going to create an analysis folder and let's do a renaming phase. So what would renaming look like? Rename is going to take the other modules that are in scope because we need to know at this point, we need to have already resolved all of the other modules that this module depends on. Otherwise, we're not able to do the proper compilation. I could avoid during a first iteration. I could avoid the problem of like, oh, the other things are already compiled and doing incremental compilation. I'm looking at resolved symbols by just not doing imports during the first phase. But that feels a bit. It feels like it's cutting too much of a corner. It's taking too much of a shortcut. So there's going to be something which is the other modules. And then we're going to take a module which has been passed. And the other overall thing is going to be either some error, actually probably even like a list of them, because we might be able to continue without having to interrupt. If we find an error, we can try to continue resolving names in other functions or something to see if we can catch all of them, or a module as we call the phase renamed. And I guess this is gonna be a hash map of module name, which we haven't defined, to a module which is gonna be for now renamed because we didn't have another type for it, but it's probably gonna be some kind of fully resolved or something. Or do I want to? No, I don't think I'm able to just do like if I go full incremental compilation, will I want to just have the IR as the input of like we're not actually storing the information. This is just the IR. This is where the things are, rather than using this preload version. This would probably be better. But I think this might require the AR to be annotated in a way that we can still do type checking during this phase. I should think about it. I haven't thought enough about it. Which is why I think we're just gonna make progress from now. And see, like I think the point of this evening is not to finish writing the renamer, make a lot of progress on the type checker. I think the point of this evening is to identify all of those things that are still unclear to me so that I can think about them for next time and have a better plan of action so that next time I know what I can schedule something a tiny bit more self-constrained. Let me put the AST here. So we have as an argument the module and with its imports and declarations. I'm almost tempted to make the import something that is just like unit after being resolved because there's not gonna be a point after type checking is done. There isn't gonna be any point in keeping the list of imports, and that's not necessarily true. It means we can do some graph analysis on like in case of circular imports or something. But for now, this is going to be exactly that. And for each declaration, do I want to carry some state? Do I need to carry some state? I probably need to, because for each function, I'm going to want to keep track of how many variables I have declared and where. So it's probably gonna be a map go declarations or something. Something along those lines. What is a declaration? Oh, this is already wrong. I'm seeing something that will not work. A name could be pointing to an enum value and not to a specific. I guess I could treat. I guess I could make it so that the exports of a module include a bunch of fake constants for the constructors of an enum, basically just ints, which means then that I don't have to worry about this. Um, indeed, a name points to a top level declaration that happens to be an enum value. I am not. I'm feeling a bit sick. I might cut it short this evening because I'm starting to feel a bit faint. So I'm gonna finish this, and I think I'll call it quits just because the fainting on camera would not be a great experience for anyone involved. So I'm gonna write as much as this as I can, and I'm gonna start to feel like, yep, nope, too queasy to continue. I'll call it for today. So I guess this is gonna be. I could avoid having a different name per. I wonder if I want to do that actually, like having some kind of like visitor pattern thing where like I associate a type class so that all of them have the same, like a traverse kind of thing. That makes sense. Could I make all of those types? Because then what that would be is basically a lens. It would be a function that, given the name of the constructor or the thing, would put that into some kind of functor. This would be a visit or over or something like this. But I would still need to introduce a bunch of functions for each of them. Yeah, no, I think it's fine to do it that way. Yeah, I've been thinking also about like using plated or something, like using more lens constructs to avoid having a lot of this manually. But I think the more I think about it, the more I have no choice but to do this manually anyway. So might as well be verbose and explicit. So renaming a type alias, I think that's what I can do. I guess I could put all of the module information in a reader, which means I could create an eval function, which is flip eval state initial name state, whatever that is. And flip run reader D with whatever the, I guess the other modules, so that I have access to all of the other modules in the reader monad, and my state monad contains whatever I need for my names, which might just be an int to know how to increment a counter for a variable name, something like this. So this would be in some monad constraint. I'm going to express this as a constraint, and I might actually specify it at the later stage, which is going to be something like we have access to the other modules, which is a hash map from module name to the renamed module. And we are in a monad state M. And we are in a monad state M, in which state is for now undefined because we haven't decided what we need. And in such an environment, rename type alias info is type alias is something that takes a type alias info past and will return a type alias info renamed. So here, the name and the parameters are not going to change. The only thing that's going to change is going to be the name type, where we're going to need to take a path and make it and resolve it, which is going to be a fairly, I wonder, not, I'm sure there's a way to express this with lenses, as in rather than doing a complete, that's something I need to look up for next time, because basically of this tree of different types, I want to explore their constructors, I want to explore their subfields to replace all of the ones that are of type path info with something else, and that needs to be returned in some kind of monadic functor context thing, which happens to be our reader for the other module, and the state for whatever incremental thing we use to assign unique local variable names to make sure we never have conflicts. The only thing is, it depends on the context, I think, as in we need to be able to know the stack of things. So that means we cannot just use some kind of lens that traverses all of the types to find all the leaves of a given type. We need to know, like, oh, we're entering a for loop. We need to shadow this name at this point because a new name that overlaps the previous one has been introduced in the scope. So I think that I think we need to have this very verbose version. I keep trying to see if I can avoid writing all of this down, but I think there isn't a way. However, this is going to be fairly straightforward because I wonder if there's a lens for something that doesn't just modify, but like apply something in a. There might be like a traverse. Because over will be expecting. Yeah, it doesn't return a functor of the thing. There is a way to do that in the statement, but that's not what I want. I guess, would that just be applying the lens by itself? I think it might be just applying the lens by itself. Yes, no need for a parenthesis for this thing. Yeah, basically the thing I'm wondering is like, I have a lens for the specific field I want to modify. Can I rewrite this as being like over the alias value, do something? And I'm fairly certain it is possible. I'm just not certain what it is. That being said, it might just be a matter of applying the lens directly, because lens takes something. Yeah, it might just be enough to apply the lens directly. So this would be alias value, and let's give it the resolve function. Ignore the location for now, and that should be the correct type, I think, if I remember my lenses correctly. And here resolve is going to be our unique function that, given this same constraint, that we're going to simplify to like a new monad type at some point, I think, will, and given a path info, will give us a resolved name. And this is going to depend on a bunch of things. It's going to depend on what our current state is that we're carrying around. It's going to depend on the representation of modules. So basically, our state is going to contain a scope, which is what we currently have in scope. It's going to need to contain then the top level declarations of our module. Again, we run into this issue of what do we do when it is something that hasn't been compiled yet in the current module? Yeah, I need to give more thought to this in terms of how to structure, and I'm currently not feeling well enough, I think, to make a lot of progress, because I am struggling to keep my balance on my chair. This is bad, so I think I'm gonna cut it short and I'm gonna lay down. I'll be back on Thursday. Hopefully by then, one, I will not be feeling queasy in front of the screen, and I'll be able to continue more. And two, I'll have time, now that I've seen what kind of issues we faced during the renaming phase, I'll have time to prepare a tiny bit more and attack this, because like again, this was okay, let's make some progress in the unknown and see what issues we face. We've raised a lot of questions this evening, which is useful because now I have a lot of things to think about how to approach this. And hopefully next time we approach this with a slightly clearer picture and a clearer goal in mind. So yeah, I think I'm gonna stop this evening just because I don't feel like I'm gonna be able to make a lot more progress. I could continue just like doing this, but like again, struggling to look at the screen right now. So I'm gonna stop here. I've started uploading all of the backlog of everything we've done so far. I'm only missing 2 streams because Twitch is very aggressive on removing old content. I'm missing the very first one, but the day I started was the day I had hardware issues, so nothing of value is really lost. And I'm missing the one evening where we found the bug in Alex, which is a bit of a shame. But otherwise, I have a copy of every single stream so far, and I've started uploading them to a second channel. When I'm feeling better this week, I'll post the link to the second channel on social media for like, here's the history of everything we've done so far, if anyone is interested. Okay, well, sorry for the slightly short and slightly less structured stream. This was still useful, I think, in terms of like seeing all the issues in front of us, so we can start thinking about them for next time. And I'll see you all on Thursday, probably.